So we'll start our deeper analysis on parallel, just looking at equations and determining what slopes would be parallel. In a question like this, I'm asking you to first identify the slope of a given equation, then state the parallel slope. So the vast majority of this section is actually a Unit 3 question. What is the slope of this equation? So you're looking first and foremost to make sure it's solved for y. It is. So then y equals mx plus b is what we're looking at. M being our slope, the number we multiply x by, tells me the slope of part A is 4. The parallel slope is the only part of this that is a Unit 5 question. It's recognizing that if my slope is 4, the slope of any line parallel is 4. These are equal, exact same thing. Okay. You guys are going to try part B on your own. Let's skip to part C real quick. The first thing I recognize is it's not y equals like part A was. So for part C, I'm going to divide everything by 3 because I need to solve for y. When I do that, I get y equals 2/3 x minus 1. Now I have it as y equals, my m, the number I'm multiplying x by, is 2/3. That's my slope, which means my parallel slope is identical, 2/3. Go ahead and press pause, then try parts B, D, and E. Remember, make sure it's solved for y, identify the slope, then the parallel slope. When you're done with parts B, D, and E, unpause to check your answers. So part B was the only one there that was actually solved for y already. We were able to identify that my x had a coefficient of 1, giving me a slope of 1 and a parallel slope of 1. In part D, I had to first subtract 5x from both sides, giving me negative 5x plus 20. Divide everything by 5, giving me y equals negative 1x plus 4. Negative 1 being my slope and my parallel slope. Part E, add 2x to both sides. This time these were like terms, so I combined them, giving me 3x. My slope is 3, my parallel slope is 3. In this next section, we have to determine whether the lines are parallel or intersecting. They're parallel if their slopes are identical. They're intersecting if their slopes are different. So we are identifying the slope of two different equations. And then we can state, hey, guess what? They're parallel or they're intersecting. This is what I'm looking to do. Find the slope of this equation. It's already solved for y, so my slope is 2. This equation is not solved for y, so I solve it for y. Add 2x to both sides. Y equals 2x plus 6. It therefore has a slope of 2. I compare these slopes. 2 and 2, exact same slope. That makes these parallel. Okay. Example 2. Do the same work. I can just use the same philosophy here. I'm doing the same work, and I'm checking. It is not solved for y. I divide by 3, divide by 3. Y equals 2/3 x. That gives me a slope of 2/3. This one is not solved for y. I divide by 2, divide by 2, divide by 2. That gives me y equals 3/2 x plus 1/2. A slope of 3/2. This slope and this slope are different. Different slope means my lines are not parallel. If they're not parallel, they intersect. I don't know anything about their intersection, I just know that they intersect. Okay, go ahead and try numbers 3 and 4. Use the same philosophy. Find the slope of the first line, slope of the second line, and compare. Press pause and do that now. So number 3, we should find them to be parallel. Both have a slope of exactly -1/2. And in number 4, they are intersecting because they do not have the same slope. In fact, they do have a very specific relationship, though. Number 4 has a negative slope. Number 5 has, or the second part of it has a positive slope. The first one is 5, the second one is 1/5. So those are what we call opposites, because one's positive, one's negative, and reciprocals. One's 5/1, one is 1/5. In that case, I do know a specific type of intersection they have, and we call that perpendicular. That's not something that we study in this class, but it is something that you will need to understand moving into geometry and algebra 2 as well. But for right now, I just need you to understand the slopes are different, therefore the lines intersect. Okay, moving on, we're going to go ahead and finish off with our next page here. This is one problem. Instead of giving you 2 equations, like I did in numbers 1, 2, 3, and 4, I'm giving you 2 graphs, or 2 tables, I should say. And we are asking you, are these parallel, perpendicular, or neither? Really, all I'm asking you is, are they parallel or intersecting? You know that based on finding the 2 slopes. If I know the slope of this one and I know the slope of this one, I know if they're parallel or not. So that's when we find our rate of change. Okay, my change in y here is 1 minus 5. That's y2 minus y1. That's a -4. My change in x is 1 minus 9. That's x2 minus x1. That's a -8. So I have a -4 over -8, which simplifies to 1/2. I'm going to compare that slope to the slope for my second table. y2 is -19 minus y1, which is -11. If you don't trust your own math skills, use your calculator. That's the same as -19 plus 11, we should get -8. x2 is 11 minus x1, which is 7, gives me +4. -8 over 4 is the same as -2 over 1. I see that in fact these two are not the same. That makes them intersecting. Like I had just mentioned, though, they do have that special relationship, 1 over 2, 2 over 1, positive, negative. I would have said that these were perpendicular if we were going to assess you on that. We will not be assessing you on that in this class, but you do need to know that moving into geometry. Okay, the last type of problem I'm looking for you to do is to graph a line that is parallel to a given line through a new point. So there's 2 major things you have to do here. First, find the slope of the given line. You do that by checking your rise and your run, or your vertical change, 1, 2, 3, 4, and down, so that's -4. And then 2 to the right, that's a +2, gives you a slope of -2 over 1. Your second step is to plot your given point, which in this case is 7, 3. So 7, 3, I plot that point and use the same slope. So I'm going to use -2 over 1 from the new point. -2 means down 2 over 1 means right 1. Down 2, right 1. Down 2, right 1. Or I could have gone up 2, left 1, up 2, left 1. Notice I'm following the exact same pattern that was followed here, therefore I am graphing a parallel line. I want you to try that same process, following that same pattern, to graph a parallel line to the given line here through the point -1, 4. Go ahead, press pause, do that, unpause to check your answer. So I haven't finished it yet, but I've done the majority of it. I found the slope of my given line is 1/2, and I plotted my new point -1, 4. Now I'm going to apply the same slope. 1/2, 1/2, 1/2. And I'm going to do that until I run out of places to plot that point. Take out my straight edge. And there is my line. Okay, good work today. We are going to go ahead and move on. You guys can go ahead and work on your homework at this point.